November 2004. A construction crew digging beneath Istanbul for $1 billion rail tunnel hits a sealed layer of waterlogged mud 6 meters down. Work halts immediately. What they'd broken into wasn't a void or a pipe, it was a lost Byzantine harbour, eventually yielding 37 ancient shipwrecks. But that was only the upper layer. Beneath it lay something that would rewrite Istanbul's origin story by 8,000 years, evidence so direct and so fragile that the race to save it became as critical as the discovery itself. The mechanical excavators of the construction consortium, Yenikapı Merkezi, had barely begun carving out the massive Yenikapi station box in November 2004 when the soil changed. 6 meters down, the dry, compacted earth gave way to a dense, waterlogged silt. As the heavy steel buckets dragged through this dark layer, they pulled up ancient timbers and fractured ceramic pieces, still slick with anaerobic mud. The physical reality of the find triggered an immediate, legally mandated halt. Under Turkey's cultural heritage conservation laws, specifically Law No. 2863, any modern construction that collides with antiquity must stop on the spot. Within hours, the Transport Ministry's transit hub transitioned from an active infrastructure corridor into an official rescue excavation zone. This sudden halt established an immediate division between two powerful entities. On one side stood the Marmaray Project Management Office, facing mounting idle time costs for their massive tunnel boring machines. On the other stood the Istanbul Archaeology museums, led by museum officials who seized control of the site. Under the law, the engineers could not move another cubic metre of earth without archaeological clearance. The routine construction schedule was dead. The ground now belonged entirely to the salvage teams, who began the slow, manual process of scraping back the wet clay. The Regional Conservation Council formalised the work stop order, turning the construction zone into a complex administrative battleground. Under Law 2863, the Ministry of Culture and Tourism assumed immediate authority over the transit corridor. Every subsequent cubic metre of displaced earth now required direct museum approval, stripping the transport planners of unilateral control. For the primary contractor, Yenikapı Merkezi, this regulatory shift triggered immediate financial pressure. Their massive tunnel boring machines sat idle, accumulating substantial delay costs, while engineers realised the original straight line rail alignment could no longer be treated as a fixed path. To resolve the impasse, the Transport and Culture Ministries established a joint steering committee, forcing a continuous negotiation between heritage preservationists and transit planners over the physical boundaries of the worksite. This collaboration produced a hybrid, ad hoc funding model. The construction consortium agreed to pay for the archaeological labour on a per cubic metre basis, with Yenikapı Merkezi directly hiring freelance archaeologists to work alongside museum staff. Meanwhile, structural engineers began planning technical workarounds, designing secant pile support walls and shifting the tunnel trajectory several metres eastward. The mega-project had transformed from a routine engineering contract into a high-stakes test case for building modern infrastructure through the deep, protected history of an ancient metropolis. The thick layer of dark, anaerobic mud sealing the Yenikapi excavation site began to reveal its true identity. Dr. Ismail Karamut, director of the Istanbul Archaeology Museums, and deputy director Zeynep Kiziltan realised the team was uncovering far more than isolated maritime debris. They had breached the perimeter of the lost Theodosian harbour. This massive artificial commercial port, established under Emperor Theodosius I during his reign from 379 AD to 395 AD, served as the primary gateway for the imperial capital of Constantinople. For 7 centuries, from the 4th to the 11th century, this basin was the economic engine of the Byzantine Empire. As the salvage teams cleared the mud, the physical infrastructure of this working maritime district began to materialise. They uncovered massive stone quays where merchant ships once docked, paved streets running along the ancient waterfront, and designated storage zones that once held goods from across the Mediterranean. The team documented stone-paved roads and structural foundations that detailed how the Roman and Byzantine administrations managed the heavy flow of maritime traffic. Huge timber piles driven into the seabed marked the boundaries of ancient piers, showing how the harbour had been engineered to handle large-scale shipping. The preservation of the wood was extraordinary. Rather than isolated fragments, the excavation exposed entire vessels embedded in the waterlogged silt. Over the course of the multi-year rescue operation, the total number of recovered shipwrecks reached 37. These vessels, ranging from small fishing boats to massive transport ships, had been trapped in the protective, oxygen-free clay when the harbour progressively silted over. The mud acted as a perfect seal, locking the wooden structures in place for centuries. This discovery fundamentally altered the nature of the Marmaray rail project. The construction site was no longer just a transportation corridor with a geological obstacle. It was one of the largest marine archaeological excavations ever conducted. The presence of 37 preserved hulls, alongside the stone quays and warehouses, forced a complete re-evaluation of the site. What began as a modern engineering contract had become an unprecedented window into the daily maritime operations of medieval Constantinople, where every square metre of excavated silt threatened to rewrite Byzantine history. To understand the actual life of this harbour, researchers under Professor Ufuk Kokabas focused on a single, extraordinarily preserved vessel, Yenikapi 14, or YK-14. This Middle Byzantine merchant ship, dating to the early 10th century, measured 15 to 16 metres in length with a 6-metre beam. When salvage teams cleared the mud from its hold, they found dozens of amphorae still packed in their original cargo positions. Inside these clay jars, the anaerobic silt had preserved the organic remains of its final cargo: pickled fish fry, walnuts, hazelnuts, almonds, muskmelon seeds, olives, peaches, and pine cones. Even the crew's personal items survived, including small bronze buckles, a wooden comb, and a clay oil lamp. The hull of YK-14 reveals a ship that spent years in active service before it sank, likely during a sudden storm. Spliced repairs along the keel and outer planking show where shipwrights patched worn timber. Because local oak became scarce over time, they used softer pine, fir, and elm for these mid-service overhauls, fastening them with a mix of traditional wooden tree nails and newer iron nails. More than a simple cargo carrier, YK-14 captures a fundamental technological revolution in maritime history. Its design represents the exact transition from the ancient shell-first construction method, where outer planks were joined first, to the modern skeleton-first system. Professor Kokabas's team documented a fully developed system of transverse frames anchored directly to a robust central keel, reinforced by long internal timber stringers. This structural shift allowed Byzantine shipyards to build vessels faster and cheaper, forever changing how goods moved across the Mediterranean. The excavation teams scraping back the silty floor of the Byzantine harbour eventually reached the bottom of the ancient basin. Beneath the thick, dark layers of marine clay lay a yellow-brown geological deposit that initially appeared to be the sterile natural bedrock. But as the trowels dug deeper, past the oldest marine sediments and into the compacted silt beneath the harbour floor, the composition of the earth changed once again. At roughly 6.3 metres below modern sea level, the researchers breached an entirely different epoch. They had bypassed the classical world entirely, descending into a prehistoric land surface that had been sealed beneath the Bosphorus for millennia. Here, preserved in the waterlogged clay, lay the physical remains of a Neolithic settlement dating back approximately 8,500 years to around 6,200 BC. This discovery instantly shattered the established timeline of the historic peninsula, pushing the known story of human habitation in Istanbul back by thousands of years. Long before the rise of Byzantium, Rome, or even the earliest Greek colonists, a thriving community had established a home on this exact spot. The physical footprint of this prehistoric site was immense, covering roughly 58,000 square metres, an area equivalent to 10 modern urban city blocks. The excavation revealed the foundations of multi-room houses constructed with irregular stones bound together by sticky mud mortar. Inside these ancient dwellings, the teams uncovered domestic features that brought the daily lives of these prehistoric people into sharp focus. Well-used hearths still contain traces of ancient charcoal, and carefully dug storage pits sat adjacent to compacted clay floors, indicating a stable, semi-permanent occupation. The material culture recovered from these lower trenches, including polished bone implements, carved stone tools, and basic hand-formed pottery, placed this community within the broader cultural and economic orbit of the Anatolian and Levantine Neolithic world. This was not a transient camp of nomadic hunters, but an organised sedentary coastal community utilising the rich resources of the local wetland. They fished the nearby waters, gathered wild plants, and practised early forms of agriculture, adapting their lives to the changing shoreline of a prehistoric lagoon. The yellow-brown silt at the base of the Neolithic layer held a physical archive of daily life that survived without stone or timber. As the excavation teams cleared the ancient shoreline of the prehistoric lagoon, they uncovered a watercourse filled with waterlogged clay. Within this dense, oxygen-free mud, they found hundreds of human footprints preserved in three-dimensional detail. Some estimates from the field recording place the number of distinct impressions at over 2,000, capturing a moment when the soft earth was freshly trodden. These impressions represent the first human trackways ever documented in Anatolian archaeology. Unlike frozen relics or discarded stone tools, these impressions offer a direct physical connection to the individuals who inhabited this shoreline. Archaeologists cleared the silt to find parallel paths running along what was once a wet bank. The size of the prints varies, suggesting a group of both adults and children walking together through the soft clay. Some tracks show distinct toe marks and heel strikes, indicating barefoot travel across the mud. Yet researchers approach these traces with scientific caution. While some interpret the parallel pathways as evidence of an organised procession, others view them as the casual, repeating steps of daily life. People walking to fishing grounds, carrying water, or returning to their shelters. The tracks do not tell a single, neat story, but rather offer a series of possibilities about movement and community presence. In this lowest trench, the archaeological task shifted. Instead of analysing stone foundations or timber beams, the researchers became interpreters of motion. They used laser profiling and structured light scanning to capture the subtle contours of the soil, recording the stride and gait of people whose physical presence lasted only seconds, yet remained locked in the earth. The preservation of these tracks transforms the ancient site from a collection of artifacts into a lived space, where the soft mud of a forgotten lagoon became a permanent record of human movement. Exposure to open air presents an immediate, destructive threat to organic materials preserved for millennia in waterlogged silt. Once excavation teams pull ancient timbers from the protective, oxygen-free mud, the drying process begins. Without immediate intervention, water evaporating from the wood cells causes the cellular walls to collapse, turning solid structural beams into warped, crumbling debris. To prevent this destruction, conservation specialists at the Istanbul Archaeology Museums and Istanbul University's Department of Conservation of Marine Archaeological Objects must immediately stabilise every piece of salvaged timber. The process requires transforming fragile, saturated wood into durable, dry structural evidence. Without this intervention, these organic artifacts would warp and splinter into useless fragments within hours of their removal from the wet clay. Inside the specialised conservation laboratories, technicians submerge the timbers in chemical baths of polyethylene glycol, a synthetic polymer that slowly penetrates the wood over months. This treatment replaces water molecules and reinforces the decaying cellular walls. For highly degraded specimens, conservators apply melamine formaldehyde resins to consolidate the fragile wood grain. Once fully impregnated, the timbers undergo vacuum freeze drying. This process sublimates the frozen water directly into gas, bypassing the liquid phase and preventing structural shrinkage. This exacting scientific labour, overseen by specialists like Dr. Burak Celebi and Dr. Isil Ozeit Kokabas, determines whether the 37 recovered shipwrecks survive as physical evidence or disintegrate. The work of these specialists turns fragile, waterlogged timber into stable archaeological data. The transition from field discovery to laboratory preservation is a multi-year commitment, where chemical precision replaces the initial excitement of excavation. Before any fragile footprint surfaces were moved or covered, the salvage teams documented the prehistoric trackways using non-invasive technologies. Technicians used structured light scanners and high-resolution photogrammetry to record every heel strike and toe impression in 3 dimensions. These digital scans captured millimetre-level depth variations in the clay, securing the physical data before exposure to the air could degrade the soft mud. Once recorded, the stabilised artefacts and ship timbers transitioned into the climate-controlled storage vaults of the Istanbul Archaeology museums. Here, the fragile organic material remains under constant environmental monitoring, protected from atmospheric changes that trigger decay. This vast archive forms the foundation of the Yenikapi long-term archaeological research programme. By converting physical remains into digital heritage datasets and geographic information systems, researchers from Istanbul University and international institutes continue to study the site's maritime and prehistoric layers. This digital curation ensures that even as the physical rail station functions above, the ancient harbour and Neolithic shoreline remain fully accessible for scientific analysis, preserving a readable record of the city's origins for future generations. Today, high-speed trains rush beneath the Bosporus, but the ground beneath Istanbul remains a living archive. As modern megacities expand, we will inevitably collide with our buried past again. The choice is no longer between progress and preservation, but how we honour the stories waiting just beneath our feet. What lies buried under your city? Let us know in the comments.